In this video, we are going to look at the difference between two squares. Now, please take note that we have some conditions that we are going to be having before we can even think of using the two. Meaning, I cannot get expressions that we got in the first examples and decide to use quadratic trinomials or difference between two squares. Now, for difference between two squares, we are going to make sure that we have the term itself says difference between two squares. So it actually means, okay, if it's difference between two squares, I need to have a difference. And it needs to be between two square numbers. So it means I have to have, my coefficients needs to be square numbers. I need to have a difference, which means I need to have a minus. But the third condition is that my powers needs to be even numbers. So the variables that I have must be powered to even numbers. So let's see. Are those conditions satisfied in the first example here? What is the coefficient of m squared? I know it's 1. So I'm looking at my coefficients that I'm looking at are 1 and 16. And I know 1 and 16 are square numbers. So tick. Then we go to the next condition. Is there a minus? Tick. Yes, there is a minus. Then I go to the variables that I'm given. I have m squared and n to the power 4. And a 2 and a 4 are even numbers. So third condition also satisfied. So it means I can go ahead and factorize by difference between two squares. So how do I factorize by difference between two squares? What I do is I square root my numbers. So remember, factorizing in general means I'm putting brackets. So I'm already going to start with opening a bracket. And if I square root 1, I'm going to get a 1. I know that I'm going to have a 1. But because there is an m there, I need to first, before I think of leaving it there, I need to confirm that it's the only thing that is left there. Then I go to my powers. I should always, remember first condition, square root the numbers, divide the powers by 2. So this is basically what I'm going to be doing, because I'm square rooting the numbers and dividing the powers by 2. So if I square root 1, I got 1. Dividing 2 to the 2 divided by 2 gives me 1. So basically I'm going to be left with m to the power 1, which is just m. Then I have my minus. Square root of 16 gives me 4. Then I go to n. Then I see that 4 divided by 2 is 2. Then I close my bracket. And because it's difference between two squares, I'm going to have to repeat this bracket again, but with an opposite sign. So this is going to be my answer. Just to minimize and create some space for the other one. M minus 4 n squared, m plus 4 n squared. Again, it could be possible that I still have a difference, still have square numbers as my coefficients, still have even powers. Then I need to factorize more. Here I have a square number next to m, 1. But m is powered to 1 and 1 is not an even number. That means one of the three conditions is not satisfied in this bracket. Therefore, I cannot use difference between two squares. I might need to use it if this m was powered 2, for example. Then it means I needed to continue, because 4 is a square number, there's a minus, the powers are even. But that's not the case, so it means I'm done. Then we go to b. First of all, square root the numbers, then divide the powers by 2. Square rooting the numbers is 4 here, x, y, because 2 divided by 2 is 1, so minus 5. That's what you have, and the same thing with the opposite sign. And I'm done. To summarize my steps, because I need to know when I'm using difference between two squares, after I know that my three conditions are satisfied, I square root the numbers, divide the powers by 2, then I repeat the same bracket but with an opposite sign. Obviously with a plus sign, because one of the conditions means I should have a minus. So the first bracket is minus, the next one is going to be a plus. Then we go to the last one. We see that we do not have square numbers here, but we know that 3 and 5 has a highest common factor. So we can factor out, we can basically factor out 3. So if we factor out 3, we will have 3. Then we are left with x to the power of 2 minus 25 y to the power of 2. Because I know 3 goes in 75 25 times. Then I see now, that was me applying common factor. Here I simply applied common factor. How do I know I can apply common factor? Because I see that although there's a minus and the powers are even, the coefficients were not square numbers. Then I see that they have something in common, so I can actually use it. But then I see that there's a 1 here and a minus and a 25. So there's a difference now in this bracket. The coefficients are square numbers. The powers are even numbers. So all my three conditions are satisfied in this bracket. That means I can actually factorize this part by using difference between two squares. So I will now square root my numbers and divide my powers by 2. So I'm going to have, remember, I cannot just decide 3 is going to be nowhere to be found. It must be carried with. Then I'm going to, if I square root 1 is just 1, and x to the power 2 divided by 2 is just going to be x minus 5, because square root of 25 is 5, y, I close it, open another one, change the sign. So I'm going to copy that with a different sign, and I'm done. But do not forget the 3. 3 is part of your factorization, so it needs to be carried with. That is difference between two squares. Want to go back and check again how, when can I use difference between two squares?